Franny has 3 feet of ribbon. Hannah has 9 feet of ribbon. How many feet of ribbon do they have all together? In terms of finding the model for this problem, when you see keywords like put together or all together or combined, when you see some of those keywords, that would let you know that it is a part whole problem or a put together problem. So this is a put together problem. You could call it a part whole. So in this one, how do we know it's a put together? They did say all together. Also, when we were given that Franny has 3 feet of ribbon, that could have been a starting value, but we didn't change it, right? We have this separate, Hannah has her ribbon, right? And that's separate. And then we put them together. So we're not changing the amount Franny has. We're putting it together with a different quantity. So whenever we do these, the equations look like part plus part equals whole. Again, that's just coming from our model sheet. So for both put together and unknown add-in, it's part plus part equals whole. And then in this case, do I know one of the parts, both of the parts? In this case, I actually do know both. I know Franny's part and I know Hannah's part. What I don't know is what that is in total when I put it all together. So then how could I draw a picture that shows that? Well, I would just go ahead and start with drawing some ribbon. So draw it however big you want it. So this is supposed to be the part that Franny has, right? So Franny has 3 feet of ribbon. And then we would put that together with what Hannah has, which is 9 feet. And I'm definitely like, doesn't necessarily need to be perfectly to scale, but should definitely look longer than the 3, right? So this is what Hannah has. And so then how would we find the answer? We put that together. We would realize, oh, well, if I just add those together, we get the total. So put the ribbon together. That's why I drew them next to each other. So 3 plus 9 would be 12. Okay, so then for our number line, we don't technically know, we're pretending we didn't already solve this with the picture. We don't technically know how far out this would go. As a teacher, you do, as you know the answer ahead of time before you've given this problem to your student. But if your student doesn't go far out enough, then you just tell them to erase and extend their number line some more. So then we could go ahead and we're not going to label like start and end because we're not going to have a starting value and an ending value. We have 2 different values and we are putting them together. So technically you could start with either one. Since we listed Franny first, I'm going to start there. So I would just start at, okay, Franny has the 3 feet of ribbon. And then I would say, okay, if Hannah has 9 feet, then I would put that together. So starting from 3, let's put 9 more with that. So we'll put it together. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm attaching, almost like I'm taping it together, right? Attaching Hannah's ribbon. And so then where I end up would be the total that they have together, in this case 12 feet. And then for the strip diagram, I know that Franny has 3 feet of ribbon. And doesn't have to be to scale, but definitely make it longer. That Hannah has 9. If I'm putting them together, then I'm looking for this total. And then the fact that I see that that total is made up of those 2 parts lets me know I need to add those two together to get the answer. So then if we look at this next one, it says Franny has some ribbon. Hannah has 9 feet of ribbon. Together they have 12 feet of ribbon. How many feet of ribbon does Franny have? So let's pretend we don't know the answer. We didn't already do the previous problem. What are we doing? We are still putting two things together. We're not changing anything. We're not comparing anything. We are taking two separate things and putting them together, right? So this is still a part-whole problem. Now, in terms of what type of part-whole problem, you might need to do your equation to figure that out. So we know it's going to look like part plus part equals whole. And so do I know both of the parts or do I know one of the parts? And the whole, in this case, I know only one of the parts, right? So Franny has some ribbon. How much? I don't know that part, right? Hannah has 9 feet, so I do know that part. Together they have 12, so I do know the whole. So in terms of which specific part-whole problem this is missing addend or unknown addend. So then let's draw a picture for this one. So I don't know how much Franny has, right? You could draw that first, or if you want to draw Hannah's first, you can do that. It doesn't really matter, right? So I don't know how much Franny has. We could just go ahead and draw it. I don't know what that is. But I could attach it to Hannah's, right? And when we do this, so I know the answer. So if I were the teacher doing this, I would draw it longer because I know that Hannah has more than Franny. But the student may not know that. That's okay. So if they don't do it to scale, if they draw this piece of ribbon shorter, that's okay. We didn't know, right? Because it's hard to compare when I don't know Franny's. But I know that that is the 9 feet. This is the 9 feet from Hannah. And then I do also know that when I put that together, I'm getting 12 feet of ribbon. So then that would help me realize that, oh, when I put them together, I get 12. So if Hannah's part was 9, the other part I would get from subtraction. That visual just kind of helps to see that. So that means that Franny had 3 feet. On my number line, I know to go ahead and start with the whole, which is 12. And so we could start there, as I know that that's what they have together. Now, I would not label it as start because it's not a starting value. But then I know that Hannah had 9 feet, right? So that's Hannah. And so then I could just find the difference there, right? And say, oh, well, if Hannah's was this part, right, all the way out to 9 feet, but together they had all of this all the way out to 12 feet, then I would just count the hops between those two. So Franny then has whatever the difference is between 12 and 9, which is 3. And then for my strip diagram, we do not know how much Franny has, but we know that if we put it together with Hannah's 9 feet, that gives us a string of ribbon that is 12 feet. And so then again, we realize that, oh, if you realize that 9 is part of the 12, then we would have to subtract to find the other. for this one, it says Miss Williams has 15 piano students. If 4 of her students are 10 years old, how many are not 10 years old? So we have this amount that we're starting with, this 15 piano students. Are we changing it, right? Are we increasing it or decreasing it? No, we're not, right? It's not saying that she's, she had 15 students and then she got more, she lost some, right? We're not changing that. So it's not really a starting value. Are we comparing it to something? No, we really aren't. We're not saying that like she has 15 piano students and 14 trumpet students, right? Like, or that Miss K has 20 piano students, right? We're not comparing it like that. We're looking at, she has 15 piano students and it's talking about some of them are 10 years old and some of them aren't, right? So we're talking about parts of a whole, right? We're talking about splitting this into parts. So this is a part whole problem. And it's a little harder to see that initially just because the first number they gave us is actually the whole, right? So we know the whole, right? And then we know the part of her students that is 10 years old. What we don't know is the other part. So this is another missing or unknown at end. So in this case, we know the whole, that's what we started with. There's 15 piano students, right? We know one of the parts, we know the part that is 10-year-olds. There's 4 10-year-olds. We don't know how many non-10-year-olds there are, so we don't know that other part. So in terms of a picture, I'm just going to draw, if you want to do stick figures, you can. I'm just going to do little happy faces because they're playing piano, they're happy. So we could say that these are her 15 students. And then since we know that's our whole, we could start splitting up our parts. So we know that the part of her students that was made up of 10-year-olds was 4 students. So just count out 4 of those and say, okay, those are the ones that are 10 years old. If those are our 10-year-olds, then everybody else is the ones who are not 10. So we could realize that, oh, I just need to subtract them, right? I need to take away that part. Or we could just count, right? So count the ones that aren't circled with the 10-year-olds. So we should just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. On the number line, since we do have the whole, any part whole problem where we know the whole, we should know how far out we need to go. And so we could go ahead and start with that number that we have all together. So we know that she has 15 students, and we know that 4 students was the number of 10-year-olds. So the difference between those would be however many are not 10 years old. So if we know that this part is representing the 10-year-olds, then that means that all of this that's left till we get to 15 is the non-10-year-olds. So I'm just going to count my hops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I wouldn't use an arrow there. So 11 people who aren't 10 years old. Then on the strip diagram, we do know she has 15 students. We know a part of those students are the 10-year-olds, and there were 4 of them. We don't know the part that are not 10 years old. And so looking at that, we realized that we could find our answer by subtracting.